somewhere inside a NOAA supercomputer right now, a number is climbing, slowly, quietly, and almost nobody in mainstream media is talking about what that number means. Because the last time it climbed this high, this fast, with this many independent systems agreeing, somewhere between 30 and 50 million people stopped existing. More deaths than every soldier killed in the First World War, combined, from a weather pattern. And here is the part that should make you genuinely uncomfortable. The scientists who studied that catastrophe didn't blame the weather alone. They blamed a very specific three-part ocean configuration, a specific combination of three ocean basins acting together in a way that no single basin could replicate on its own. That paper was published in the Journal of Climate in 2018. The lead author was a climate scientist named Deepti Singh, and what she found, what her team documented using modern attribution methods applied to the worst climate disaster in recorded human history, is that the Pacific Ocean alone did not kill 50 million people. The Pacific was the headline, but the mechanism required something more. Two other oceans, moving in the same direction at the same time. As of right now, in the spring of 2026, all three of those basins are beginning to move into position. Stay with me until the end of this video, because what is assembling in the data right now has a name, and it is time someone said it out loud. If this has you hooked, subscribe to Stellar so you don't miss what comes next. Because this story is going to keep developing as new data comes in over the next several months, and you will want to be here when it does. Drop a comment below. I want to know where in the world you're watching from, what time it is where you are, and your honest take on this. 3 ocean basins, 1 historical precedent, 50 million people. Is the world paying attention? Tell me what you think. Now settle in, because we've got a lot to unpack. Part 1. The forecast that shouldn't exist. The ocean is quiet right now. Not metaphorically quiet, literally, measurably, statistically quiet. If you pull up the Oceanic Niño Index today and look at the number sitting in the most recent column, you will see something close to 0.16 degrees Celsius. That is a number so close to zero that most climate scientists would shrug and call it neutral. Not warm, not cold, not interesting. Just the ocean doing its thing, drifting along in a state of unremarkable equilibrium that would make any forecast desk look at it and decide there is nothing particularly urgent to discuss this week. So here is the problem. The models don't agree with the ocean. Not one model. Not a rogue outlier running experimental physics on a server farm in Boulder. We are talking about the 2 most closely watched, most institutionally trusted, most independently constructed climate forecast systems on the planet. NOAA's Climate Forecast System version 2, known as CFS-V2, and the North American Multi-Model Ensemble, known as the NMME, 2 entirely separate systems, built on different code, different physics, different assumptions about how the ocean and atmosphere exchange heat and momentum, and both of them, right now, in the spring of 2026, are pointing at the same number. A number that the last time the real world actually produced it ended more lives than the combined military fatalities of the First World War. That number is positive 2.0 degrees Celsius or higher in the Niño 3.4 index, the threshold climate scientists use to define a super El Niño, a category that has only been confirmed 3 times in the modern instrumental record: 1982 to 83, 1997 to 98, and 2015 to 16. The models right now are not projecting a modest El Niño. They are not projecting a strong El Niño. The carbon brief analysis of 637 model runs from 13 separate modeling groups published in late April 2026 found a central median estimate of positive 2.2 degrees Celsius by September. That would put this event firmly in Super El Niño territory, and warming typically strengthens further after September as El Niño conditions peak between November and January. That number needs context. The International Research Institute for Climate and Society at Columbia University, which maintains one of the most widely cited ENSO probability forecasts in the world, is currently showing roughly 70% El Niño probability for the April to June window, rising to between 88 and 94% through the rest of 2026. NOAA's Climate Prediction Center puts the odds of a Super El Niño specifically, Niño 3.4 at or above positive 2.0, at 1 in 4, a 25% chance of crossing the threshold that has only been crossed 3 times in the instrumental record. Here is what makes that convergence genuinely unusual. This is happening during what climate scientists call the spring predictability barrier. In every spring, roughly between February and May in the Northern Hemisphere, the ability of climate models to accurately forecast El Niño events drops to its lowest point of the year. The coupling between the ocean and the atmosphere in the tropical Pacific is weakest during this window. The signal the models are trying to detect is partially buried under natural variability. Forecasters know this. It is not a bug in the models. It is a feature of the real climate system. And historically, many El Niño forecasts that looked convincing in the spring have simply failed to verify by autumn. So we have 2 of the most trusted modeling systems on Earth converging on a Super El Niño forecast during the period of the year when ENSO forecasts are statistically the least reliable, are from a starting point where the ocean itself reads as neutral. That combination of factors should, under normal circumstances, produce a lot of caveats and a lot of hedging. Instead, the WMO's Global Seasonal Update, issued in late April 2026, described the model ensemble as showing a nearly unanimous trajectory toward El Niño by May, with tight clustering of the models despite the typical spring predictability barrier. Severe Weather Europe, reporting on the latest CFSV2 output just 2 days ago, described a developing event rivaling even some of the strongest Super El Niño events in recent history. The models are not whispering. They are walking toward a specific number with quiet, methodical confidence. And the reason that number matters, the reason this is not just another El Niño forecast story, then is a peer-reviewed paper published in 2018 that most climate journalists have never read. A paper that looked backward at the worst drought in recorded human history and figured out, not approximately, not vaguely, exactly what caused it. Part 2. The number and what it represents. Positive 2.0 degrees Celsius in the Niño 3.4 index doesn't sound like much. It sounds like the kind of number you'd find in the footnote of a meteorology report. A small technical decimal point problem, the kind that belongs to scientists and not to anyone who has to actually live in the world. But that number in the Niño 3.4 index is not a small technical problem. It is the threshold at which the Pacific Ocean stops being a background condition of the global climate system and starts being an active force that reorganizes it. Let me tell you what the 3 confirmed Super El Niños in the instrumental record actually produced, because the historical record is the only honest benchmark. The 1982-83 event peaked at roughly positive 2.2 degrees Celsius. At the time, it was the strongest El Niño ever recorded. It caused severe drought across Australia, southern Africa, and parts of South and Southeast Asia. It triggered catastrophic flooding across Ecuador, Peru, and East Africa. Economic losses ran to billions of dollars across multiple continents, and it occurred in a world roughly 0.3 degrees Celsius cooler than today. The 1997-98 event peaked at approximately positive 2.4 degrees. It held the record as the most powerful El Niño ever measured until 2015. Indonesia burned. Reefs bleached across the Pacific. Drought devastated crops across the Philippines, Australia, and large parts of Africa. Flooding killed thousands across South America and East Africa. Economic damage ran into the tens of billions. The 2015-16 event matched or slightly exceeded the 1997-98 event in some indices, and it did so on a baseline global temperature already roughly 1 degree Celsius above pre-industrial levels, which meant the absolute sea surface temperatures involved, not just the anomaly, but the actual temperature of the water, were higher than in any previous super event. The impacts were correspondingly amplified. What the current forecast is projecting, a central estimate of positive 2.2 degrees Celsius by September, with strengthening expected toward peak, puts this event in the same magnitude class as both of those historical benchmarks. And that comparison is not reassuring. It's because even the devastating 1997-98 event, the one climate scientists routinely use as the reference case for a super El Niño, did not have the multi-basin configuration that Deepti Singh identified in the 1876-78 event. The 1997-98 El Niño was one basin acting close to alone. It killed tens of thousands. It caused tens of billions in damage. It disrupted food systems across multiple continents. And it was not what killed 50 million people in 1877. That required something more. Part 3. The ocean already made its decision. What you see on the surface of the Pacific Ocean right now is a neutral ocean. What is underneath it is something else entirely. This is one of those cases where the surface appearance of a thing is almost the opposite of its actual condition, and like a frozen lake that looks solid and safe until you step on it and hear the crack beneath your feet. The Oceanic Niño Index, the number that appears in news headlines when someone bothers to cover this topic, is a surface measurement. It tells you what the top layer of the Pacific is doing. It does not tell you what is happening 100 meters down or 200 meters down in the warm water reservoir that climate scientists call the subsurface heat content of the Western Pacific. And right now, what is happening down there is the key to understanding why the surface models are forecasting what they are forecasting. The Western Pacific Warm Pool, the region of ocean east of the Philippines and northeast of Australia, is one of the warmest bodies of open ocean water on Earth. In a La Niña state, the opposite of El Niño, in the trade winds act as a pump. They push warm surface water westward. It piles up in the Western Pacific. It accumulates, it deepens, it gets stored in the subsurface like a giant thermal battery. The ocean doesn't lose that heat easily. Once warm water sinks below the surface mixed layer, it is insulated from the atmosphere above. It sits there, waiting. The early months of 2026 showed sea surface temperatures in the Western Pacific Warm Pool running between 29 and 30 degrees Celsius, at or near the thermodynamic ceiling of tropical ocean surface temperatures. But the more important measurement is what the Argo floats and the Tau/Triton mooring array, the network of ocean sensors providing real-time subsurface data across the tropical Pacific, are showing at depth subsurface temperature anomalies in the western and central Pacific are significantly positive. The warm water is there, and it is not sitting still. What happens next in an El Niño event is driven by something called equatorial Kelvin waves. A Kelvin wave in this context is not a crashing breaker on a beach. It is a slow, enormous disturbance in the thermocline, the layer of ocean where temperature drops sharply with depth, that propagates eastward along the equator. When the trade winds weaken or briefly reverse, they release the warm water that has been piling up in the western Pacific. That warm water moves eastward as a Kelvin wave, depressing the thermocline as it goes, causing the layer of warm surface water to thicken progressively as it propagates toward the central and eastern Pacific. Then when those waves arrive off the coast of Peru and Ecuador, they cause the thermocline to deepen and the sea surface to warm. That warming is the surface expression of El Niño. But the heat was already there, in the subsurface, weeks to months before the surface showed anything anomalous. Here is what that means for the current forecast. El Niño is not the buildup. El Niño is the release. The pressure builds for months or years in the western Pacific, while La Niña conditions pump warm water westward. And when the trade winds weaken and the system tips over, all of that stored energy begins its eastward journey toward the surface. By the time the Niño 3.4 index crosses positive 0.5, and someone on television announces that El Niño has officially begun, the decision was made months earlier, in the subsurface, and in the heat content of the water column, in the physics of Kelvin waves already in transit. NOAA's official April 2026 diagnostic confirmed. El Niño is likely because of increasing subsurface temperature anomalies and recent westerly wind anomalies over the western Pacific Ocean. The ocean is leaning. The models are reading that lean, and they are projecting where it leads. Part 4. What the Singh paper actually found in 2018. Deepti Singh and her colleagues published a paper in the Journal of Climate. The title was Climate and the Global Famine of 1876 to 78. It is not a famous paper. It does not get synthesized into TED Talks. It was read primarily by climate scientists and atmospheric researchers and almost no one else. But what it found is by any serious measure one of the most important pieces of attribution science produced in the last decade. Its central finding is this: El Niño did not kill 50 million people in 1877. Not alone, not by itself. El Niño was the headline. But the mechanism, the specific physical configuration that turned a climate event into a global catastrophe, required 3 ocean basins acting in a synchronized pattern that amplified each other's effects into something no single basin could have produced on its own. The paper's abstract states directly, total human fatalities likely exceeding 50 million. The extreme severity, duration, and extent of the event is associated with an extraordinary combination of preceding cool tropical Pacific conditions from 1870 to 76, a record-breaking El Niño from 1877 to 78, a record-strong Indian Ocean dipole in 1877, and record-warm North Atlantic Ocean conditions in 1878. A record-breaking El Niño, the strongest since 1850, bigger than 1997 to 98, bigger than 2015 to 16. A record-strong Indian Ocean dipole, the strongest ever documented, and a record-warm North Atlantic, all 3, simultaneously, and the paper is explicit. The magnitude and global extent of the 1876 to 78 drought cannot be reproduced by Pacific forcing alone. That sentence is the key to understanding why everything about the current forecast situation requires a different frame than any standard El Niño analysis. Here is the Pacific piece. El Niño in the central and eastern Pacific suppresses rainfall across a broad swath of the tropics and subtropics through a mechanism called the Walker circulation, a large-scale atmospheric pattern that normally brings moisture-laden air westward across the Pacific, rising over the warm pool, generating rainfall, and returning eastward at upper levels. When El Niño warms the central Pacific, the warmest water shifts east. The rising branch of the Walker circulation shifts with it, and the regions that normally benefit from that rising moist air are left in the subsidence zone, where the circulation descends, suppressing rainfall. That is the Pacific piece. It is real, well documented, and dangerous enough on its own. But the Pacific piece alone does not explain 1877. The second component is the Indian Ocean dipole. In its positive phase, the Western Indian Ocean anomalously warm relative to the Eastern Indian Ocean. It significantly alters the behavior of the South Asian monsoon. The monsoon delivers approximately 80% of India's annual rainfall. It sustains agriculture across the Indian subcontinent, Pakistan, Bangladesh, and much of Southeast Asia. A system that feeds roughly 2 billion people. In a positive IOD state, the atmospheric circulation over the Indian Ocean reorganizes in a way that weakens the moisture flow into the subcontinent, reducing monsoon rainfall, increasing drought risk. A positive IOD occurring simultaneously with a strong El Niño does not simply add its drought signal to the El Niño signal. The atmospheric teleconnections interact. In some configurations, they reinforce each other in a way that produces droughts more severe than either could produce alone. In 1877, the Indian Ocean dipole was in its strongest ever recorded positive phase. The monsoon failed catastrophically across large portions of the subcontinent. The third component is the North Atlantic, an anomalously warm. North Atlantic sea surface temperatures alter global atmospheric circulation through teleconnections that climate scientists are still working to fully characterize. They affect moisture distribution in the upper troposphere. They modified the position of subtropical jet streams. They change large-scale pressure patterns that govern where rainfall does and does not go across Africa, South America, and beyond. In isolation, the Atlantic warming of 1877 would not have been enough to produce catastrophic drought. Combined with a strong Pacific El Niño and a record positive Indian Ocean dipole, it functioned as a third reinforcing force, an additional weight on an already precarious global moisture balance. And the result of all three acting together was something that tree ring reconstructions and paleoclimate proxy records describe as the worst drought in at least 800 years. The failure of monsoons across Asia, the simultaneous collapse of rainfall across sub-Saharan Africa and Brazil, synchronized crop failures across multiple continents that share no borders but share a climate system. All of it traced back to this triple alignment, and a 2021 paper in NPJ Climate and Atmospheric Science confirmed the compound effect mathematically. Compound drought probability is approximately 3 times higher during El Niño conditions compared to neutral, but it is approximately 7 times higher when cold tropical North Atlantic conditions co-occur with El Niño. 7 times, not 3, not 4, 7. Now let's talk about 2026. Part 5. The Triple Basin Alignment. Right now, the Pacific is warming. The models are projecting a super El Niño. That part of the alignment is in active development, confirmed by 637 model runs from 13 modeling groups, confirmed by NOAA, confirmed by the WMO, confirmed by the IRI. The Indian Ocean is trending toward a positive IOD phase. The Australian Bureau of Meteorology, as of April 26, 2026, reports the IOD index at positive 0.09 degrees Celsius, currently neutral, but the direction is established. The IRI's April 2026 forecast shows 4 out of 6 models exceeding the positive IOD threshold by June, remaining in positive territory through October, while the WMO's Global Seasonal Update confirms the IOD plume forecasts a shift from near-average conditions toward a positive IOD phase. Climate Impact Company's analysis puts it directly: moderate to strong positive IOD forecasts to emerge with El Niño mid to late 2026. The IOD has not committed. The magnitude is uncertain. But the seasonal evolution of the IOD is such that its peak typically occurs in the Northern Hemisphere autumn, exactly when El Niño is also approaching its peak. If both systems peak simultaneously, their monsoon suppression effects over South Asia and Africa would be adding rather than cancelling. The North Atlantic is anomalously warm. This is not a forecast, it is a current observation. The WMO's Global Seasonal Update confirms above normal SSTs persisted across the extratropical North Atlantic. North Atlantic sea surface temperatures have been running at historically elevated levels for 2 consecutive years. The debate in the scientific community is about the cause, whether it reflects reduced aerosol emissions from shipping fuel regulations, long-term ocean heat content accumulation, or natural variability. The debate about cause matters less for our purposes than the observable fact of condition. The North Atlantic is warm. It has been warm. The evidence does not suggest it is about to cool dramatically in the near term. So, Pacific warming trajectory pointing towards Super El Niño. Indian Ocean trending positive EOD. North Atlantic already anomalously warm for the 2nd consecutive year. If this is not the full alignment, the IOD has not committed. The magnitudes are uncertain. The atmospheric coupling between basins is complex and not deterministically predictable. There are multiple ways this configuration could fail to fully replicate the 1877 setup. But the directional trend across all 3 basins is simultaneously pointing in the direction that Deepti Singh's team identified as the mechanism behind the worst climate catastrophe in the modern record. And the mainstream conversation about the current El Niño forecast is almost entirely Pacific-centric. It asks, how strong will it be? When will it peak? Which regions will get drought and which will get flooding? These are legitimate and important questions, but they are missing the question that the Singh paper makes unavoidable. The question is not just whether we get a Super El Niño in the Pacific. The question is whether we get a Super El Niño in the Pacific while the Indian Ocean simultaneously amplifies the monsoon failure and the North Atlantic simultaneously adds its weight to the global circulation disruption. Because that compound configuration, that teleconnection stacking, is not just the sum of 3 climate events. It is something qualitatively different from any one of them. It is what turns a climate anomaly into a system-level disruption. And the forecast that most people are watching is only telling you about one of the 3 instruments in that ensemble. The other 2 are already tuning up. Part 6. The 1876-78 event reconstructed. There is a way to talk about historical climate catastrophes that makes them feel distant and abstract disasters that befell people who lived in a different technological epoch. Tragic, but separate from anything we need to worry about today. That framing is comfortable. It is also wrong. the 1876-78 event, sometimes called the Great Drought, sometimes the Victorian Great Famine, sometimes referenced through the lens of specific regional disasters like the Grande Seca in Brazil or the simultaneous famines across India and China, was not a regional event dressed up in global language. It was a genuinely global climatic disruption that affected every inhabited continent simultaneously. And that simultaneity is the specific feature that made it catastrophic in a way that no single regional drought could replicate. To understand the scale, you have to start with the monsoon. In 1876, the South Asian monsoon, the seasonal rainfall system that brings approximately 80% of India's annual precipitation between June and September, effectively collapsed across large portions of the subcontinent. Not weakened, not underperformed, collapsed. Rainfall in some regions was less than 25% of normal. The failure extended across not just one season, but 2 consecutive years, with 1877 repeating the drought that 1876 had begun, across a subcontinent with a population of roughly 250 to 300 million people, the majority of whom were subsistence farmers entirely dependent on that rainfall for their food supply. 2 consecutive failed monsoons was not a stress on the agricultural system. It was the destruction of it. And the word simultaneously is doing enormous work in this sentence, so I want you to hold it. Across China's Shaanxi, Shanxi, Henan, and Shandong provinces, the Yellow River Basin, the agricultural heartland of one of the world's most densely populated regions, drought conditions of severity that tree ring records suggest had not occurred in at least 3 to 4 centuries. The death toll in China alone from the 1876 to 79 period, sometimes called the Incredible Famine or the Dingwuji, has been estimated by historians at between 9 and 13 million people. That estimate alone is larger than the total military deaths of the United Kingdom in the entire Second World War, and that was still only part of it. Across sub-Saharan Africa, rainfall systems that multiple communities and agricultural systems depended on failed across the same 1876 to 78 window. Brazil's Nordeste region, the semi-arid interior known as the Sertão, experienced what became known as the Grande Seca. The Great Drought, a 3-year rainfall failure so severe, it killed an estimated 500,000 people in a region whose total population was only a few million, and triggered mass migrations that reshaped the human geography of Brazil for generations. In southern Africa, in the Deccan Plateau of India, in the coastal regions of East Africa, the same story repeated with regional variations. The global simultaneity of all of these events is what the paleoclimate record confirms. Tree ring studies assembled from sites across Asia, the Americas, Africa, and Australia consistently showed the 1876 to 78 period as one of the most globally coherent drought events in at least 800 years of reconstruction. Not the most severe in any single region necessarily, but the most globally synchronized. It's the event where drought signals across the most distant and separated parts of the planet all pointed in the same direction at the same time. The population of the world in 1876 was approximately 1.4 billion people. The death toll attributed to the climate-triggered famines of 1876 to 1879, confirmed directly in the abstract of the Singh et al. 2018 Journal of Climate paper, is described as total human fatalities likely exceeding 50 million. That is not a vague historical estimate. That is the considered conclusion of a peer-reviewed attribution study published in one of the most rigorous climate science journals in existence. even the lower bound of historical estimates, 30 million represents roughly 2% of the entire human population of the Earth at the time. The upper bound approaches 3.5%, and those numbers were not produced by an El Niño of unusual meteorological severity acting alone. They were produced by the specific multi-basin alignment, the Pacific, the Indian Ocean, and the North Atlantic acting together, forcing simultaneous drought across every major agricultural system on the planet at the same time. Part 7. Why 50 million died. The uncomfortable truth about the 1876 to 78 famines is that the climate made them possible, but the human systems made them lethal. This is not a comfortable argument, and it is not one that lets anyone off the hook. Not the climate, not the institutions that managed its consequences, but it is the argument that the best historical and economic scholarship on this period has converged on, and understanding it is essential to grasping why the risk calculus for a modern analog is so different from simply rescaling the 1877 death toll to today's population. Mike Davis, in his exhaustive examination of the Victorian famines, coined the term late Victorian Holocaust. The word was deliberate. His argument was that the scale of death achieved in 1876 to 79 was not simply the result of drought. It was the result of a specific economic and political system, British colonial administration in India and across Africa and Asia, that made populations maximally vulnerable to climate stress and then failed catastrophically to mitigate it. Consider the specific mechanism in British India. The British colonial government, operating under the economic orthodoxy of the time, maintained the export of grain from India throughout the famine. This is the detail that historians return to again and again. While millions of Indians were dying of starvation, grain continued to flow out of Indian ports to British and international markets because the market price in those export markets was higher than the purchasing power of starving subsistence farmers in the interior. The grain was physically present in India. The market mechanism dictated that it would not stay there. The railroad network, which the British had built across India partly for strategic military purposes and partly to facilitate resource extraction, the function during the famine not primarily as a distribution network for relief, but as a mechanism for price arbitration. Grain dealers used the railroad to move food toward higher-priced urban and coastal markets, which in practice meant moving it away from the famine zones where subsistence farmers had no purchasing power. The railroad accelerated the extraction of food from the regions that needed it most toward markets that could pay more for it. British famine relief policy, where it existed, was often deliberately designed to minimize cost. Relief camps were established but understaffed and undersupplied. Food rations in some camps were calculated at levels below what was available to prisoners in Auschwitz. As Davis notes, with deliberate harshness, as the political will to intervene at a scale commensurate with the human crisis was absent, partly because the ideological framework of the time made mass death by market forces seem more philosophically consistent than the alternative of market intervention. In Qing China, the situation was structurally similar, though politically distinct. The Qing dynasty, already weakened by decades of internal conflict and external pressure, lacked the administrative capacity and fiscal resources to respond to the scale of the drought across the northern provinces. The traditional famine relief systems had been disrupted by the upheavals of the mid-19th century. The crisis hit an already weakened state apparatus. Why does any of this matter for 2026? Because the Singh et al. Paper makes something explicit that purely climate-focused discussions leave implicit. The 50 million dead were not killed by the climate event alone. They were killed by the combination of a climate event that created synchronized global stress and human systems that were not designed or were actively designed not to manage that stress equitably. The climate created the pressure. The institutions determined whether that pressure was absorbed or passed through to the most vulnerable populations. The modern global system has different institutions. It has food aid organizations, international commodity markets, early warning systems, national governments with generally greater capacity for response than Victorian-era colonial administrations. These systems genuinely matter, and a direct repeat of 1877 is not what a verified triple basin alignment would produce in 2026. And I want to be clear and honest about that. But the more important question for today is not whether modern institutions can prevent a repeat of the mortality rate of 1877. The more important question is whether modern institutions, including global food supply chains that have become extraordinarily interconnected, commodity markets that transmit price shocks globally within hours, and political systems that face intense domestic pressure when food prices rise, can manage the stress of a synchronized global drought signal without themselves introducing new and different failure modes. And that question does not have the same comfortable answer. Part 8. The baseline has shifted. Here is something that is easy to say, but harder to fully grasp. Every El Niño that occurs from this point forward in human history will occur in a different climate than every El Niño that occurred before roughly 2015. Not a slightly different climate, not a marginally warmer background state, a measurably physically distinct climate system in which the baseline sea surface temperatures, the atmospheric moisture content, the land surface conditions, and the thermodynamic limits on extreme events are all shifted relative to the pre-industrial reference state. The current global mean surface temperature is running approximately 1.2 to 1.5 degrees Celsius above the pre-industrial baseline. That number sounds small in the same way positive 2.1 degrees Celsius in the Niño, 3.4 index sounds small. And in the same way that the Niño index number stops sounding small once you understand what it means for global atmospheric circulation. The global warming baseline stops sounding small once you understand what it means for the behavior of climate events operating on top of it. Start with the most basic thermodynamic implication. The atmosphere holds water vapor, the fuel for rainfall and storms. The Clausius-Clapeyron equation tells us that for every 1 degree Celsius of warming, the atmosphere can hold approximately 7% more water vapor, 7% more fuel available for precipitation events. That sounds like it should mean more rainfall everywhere. It does not. The additional moisture intensifies the wet regions and the dry regions simultaneously. Wet areas tend to get wetter, dry areas tend to get drier. The contrast between rainfall-suppressed regions and rainfall-enhanced regions, which is exactly what El Niño creates through its influence on global atmospheric circulation, is amplified by the additional moisture capacity of a warmer atmosphere. In concrete terms, this means a super El Niño in 2026 would impose its drought signal on the same regions it would have affected in 1877. South Asia, Sub-Saharan Africa, northeastern Brazil. But on a background climate state, where the thermodynamic potential for extreme dryness is higher than it was in the Victorian era. The soil moisture deficits that develop during El Niño droughts are deeper when they start from an already stressed soil moisture baseline. The heat waves that accompany El Niño-related drought are more intense when superimposed on a warmer mean temperature, and the feedback loops that sustain and amplify drought conditions, dry soil, reduced evaporation, suppressed rainfall, further soil drying, are more easily triggered and harder to break in a warmer climate. There is a concept in climate science called loading the dice. Anthropogenic warming doesn't make specific extreme events certain. It shifts the probability distribution of outcomes in a way that makes extreme events more likely. An unloaded die might show double sixes roughly 3% of the time. A loaded die might show double sixes 10 or 15% of the time. You still cannot predict any individual role, but the frequency and intensity of the extreme outcomes increases systematically. The climate system is now playing with loaded dice in a way it was not in 1877. The same atmospheric forcing, the same multi-basin ocean configuration, it will produce more intense surface climate anomalies in the 2026 climate than it would have in the 1876 climate. Not because the ocean forcing is necessarily stronger, because the thermodynamic response of the atmosphere and land surface to that forcing is amplified by the higher baseline temperature. And when a Kelvin wave propagates eastward in the Pacific right now, it is doing so through an ocean that is warmer at depth than it was during the 1997-98 event. When that warm water surfaces in the eastern Pacific, it does so against a background of already elevated sea surface temperatures. Higher absolute temperatures mean more evaporation, more moisture in the atmosphere, stronger amplification of the atmospheric circulation changes that El Niño drives. The Singh et al. Configuration, if it fully materializes in 2026, Mach would be expressing itself through a climate system that amplifies its effects beyond what the same configuration produced in 1877. The physical intensity of the climate signals would likely be greater. The stress imposed on modern agricultural systems and food supply chains, which were built and optimized for the climate of the last century, would be correspondingly greater. Part 9. The global food system is one machine. In 1877, the world's food systems were not connected, not in the way they are today. There were global food markets in the Victorian era. Grain from the American plains was already being exported to Britain and Europe. Colonial food flows connected India and Southeast Asia to European trading networks. But the connectivity was partial, slow, characterized by enough redundancy and regional self-sufficiency that a crop failure in one region did not instantaneously propagate into a price crisis in another. When the Indian monsoon failed in 1876, the primary mechanism by which that failure killed Indian farmers was not the global market. It was the absence of local food reserves combined with colonial policies that prevented redistribution. The failure was local in its immediate expression, even if its climate cause was global. The 2026 global food system is categorically different. It is not a collection of regional food systems with some trade connections between them. It is a single, deeply integrated global machine, a system of production, transportation, storage, commodity trading, and distribution that operates in continuous real-time across every country on Earth, optimized over decades for efficiency rather than resilience. That optimization has produced extraordinary results. Global food prices have trended downward in real terms for most of the last half-century. Caloric availability per capita has increased. Hundreds of millions of people who would have faced food insecurity under pre-modern agricultural productivity now have consistent access to adequate nutrition. These are genuine achievements, and they are not trivial. But the same optimization for efficiency that produced these achievements has a specific structural consequence: the removal of buffers, buffer stocks, the grain reserves, the storage capacity, the slack in supply chains that allows a system to absorb a shock in one part without propagating that shock throughout. These have been systematically reduced as modern supply chain management has moved toward just-in-time models, just-in-time delivery, in which food moves through the supply chain in close synchrony with demand rather than being stored at multiple nodes, is maximally efficient under stable conditions and maximally fragile under disruption. When the stable conditions assumption breaks down, when a major production region fails to deliver its expected output, there is less buffer in the system to absorb the gap, and price signals propagate faster and more sharply. Walk through what the current forecast configuration would mean for the global food system if it verified. India is the world's largest exporter of rice and one of the major exporters of wheat. A significantly failed South Asian monsoon, the kind that are coincident strong Pacific El Niño and positive Indian Ocean dipole would be expected to produce based on historical precedent, would reduce Indian agricultural output across a range of staple crops. India's response historically and by current policy precedent would include export restrictions, bans or tariffs on rice and wheat exports designed to protect domestic food availability. India has done this repeatedly in recent years, including during price spikes in 2022 and 2023. The announcement of Indian export restrictions sends an immediate price signal through global commodity markets. Because India is large enough in global rice markets that its absence as a supplier creates a real supply deficit that other producers cannot quickly fill. Simultaneously, and if the same multi-basin configuration produces below normal rainfall in sub-Saharan Africa and northeastern Brazil, which historical teleconnection patterns and the Singh et al. Attribution suggest it would, the global production of multiple staple crops would be simultaneously reduced in several of the world's major growing regions. The global commodity markets would be absorbing reduced supply signals from multiple major production zones at the same time, rather than sequentially. The difference between sequential shocks and simultaneous shocks in a tightly coupled market system is not linear. Sequential shocks allow time for adjustment, substitution, and reserve drawdown. Simultaneous shocks overwhelm these mechanisms because the adjustment options that cushion any one regional shock are themselves impaired by the other regional shocks happening at the same time. The model for what this looks like in practice is not hypothetical. The 2010-11 commodity price spike, driven in part by a Russian wheat export ban following a heatwave combined with simultaneous production shortfalls in Australia and Pakistan, saw global wheat prices roughly double in a 6-month period. That event contributed to social instability across the Middle East and North Africa. It is cited by analysts as one of the background conditions that made the populations of those regions susceptible to the political disruptions of the Arab Spring. And the 2010-11 event was not a full triple basin alignment, and it was a coincidence of regional climate stresses, not a globally coherent forcing pattern of the kind the Singh et al. Analysis describes. The geography of vulnerability has not changed as much as the nature of the system has. High-income countries have the purchasing power to outcompete lower-income countries for available food supplies when prices spike. The populations that bear the greatest burden in a synchronized global food price shock are precisely the populations that Singh et al.'s historical analysis identified as the most devastated in 1877. Sub-Saharan Africa, South Asia, parts of the Middle East. The modern system prevents Victorian-scale mortality, but it distributes the economic pain of a synchronized climate shock in ways that are not uniform. And populations that already spend a larger share of their income on food have less buffer and less institutional capacity to absorb the economic shock. Part 10. The Spring Predictability Barrier. Every honest investigation of this subject has to stop here. The spring predictability barrier is real, it is significant, and it has humbled confident ENSO forecasts before. The physical basis is not complicated. The tropical Pacific Ocean atmosphere coupling goes through a seasonal minimum during boreal spring. The signal the models are trying to detect is partially masked by atmospheric noise that is decorrelated from the ocean state. The models are trying to read a message written in pencil against a background of ink. Historically, our forecasts made during the spring predictability barrier have had lower skill than forecasts made at other times of year, and the track record of enthusiastic spring forecasts is not unblemished. In 2014, the Pacific developed conditions that models were confident would produce a major El Niño. Strong subsurface heat content, weakening trade winds, early Kelvin wave activity. The forecast plume in early 2014 looked broadly similar to what we see in early 2026. The event failed to fully develop. The trade winds recovered. The subsurface heat was partially redistributed without producing the expected surface warming. What emerged was a modest El Niño rather than the super event many models had projected. The 2014 near miss is the cautionary tale that every ENSO forecaster carries with them. So the spring predictability barrier is real, and the 2014 analog is real. Both of them counsel humility about the current forecast convergence. What makes the current situation different from the typical spring barrier scenario is a combination of factors. NOAA's April 2026 diagnostic confirms the subsurface heat content is substantially above the threshold that historically precedes major events. In 2014, the subsurface anomaly was real, but limited in depth and extent. What the Argo floats and Tau/Triton array are recording in 2026 is a more deeply established thermal anomaly, one that is less susceptible to atmospheric noise because it is anchored in ocean physics that the spring barrier's atmospheric noise cannot easily disrupt. The Kelvin waves are already in motion. The heat content is already positive. The models are reading the physical state of the ocean. The IRI's 70% El Niño probability, maintained during the period of historically lowest forecast skill, reflects the collective judgment of forecasters who know about the barrier and are applying it as a discount to their confidence. That 70% is not a naive reading of the model output. It is the model output after experienced forecasters have already discounted it for the barrier effect, and it is still 70%. A 30% chance of El Niño failing to develop is not a reason to ignore the 70% chance that it does. The barrier reduces confidence. It does not invalidate the signal. The most important observation windows over the coming months are the evolution of trade winds in the central and western Pacific, the rate of SST warming in the Niño 3.4 region as the barrier recedes, and the behavior of subsurface heat content in the eastern Pacific as the Kelvin waves complete their transit. Those indicators, more than any model output, will tell us which scenario we are living in. Part 11. What this is not. Before we move toward what happens if the configuration verifies, a deliberate pause. Because we are now at the point in a video like this where the internet tends to do what the internet does. So let me be clear and specific about what this story is not. It is not a geoengineering story. The Pacific warm pool, the reservoir of thermal energy currently loaded with heat and moving eastward in subsurface Kelvin waves, contains more thermal energy than the entire human civilization has released by burning fossil fuels across the complete industrial period. Not in a recent decade, and not in a particularly bad year. Across the entire history of industrialization, from the first coal-fired steam engine to today. Any technology capable of meaningfully modifying that reservoir at the scale required to produce a super El Niño would need to operate at a power level that would itself be the most significant energy event in human history. Visible, measurable, impossible to conceal from the global network of ocean sensors, atmospheric monitoring stations, and independent scientific institutions operating across dozens of countries with competing national interests. The anomalies the models are detecting are driven by ocean heat physics, not by classified technology. The numbers are not close. It is not a solar story. Solar cycle 25 is tracking toward a moderately active maximum. The global temperature effect of a solar cycle of this magnitude is on the order of 0.1 degrees Celsius over the full 11-year cycle. A 2 degrees Celsius warming in the Niño 3.4 index does not have a solar cycle explanation. The solar forcing is not large enough. It is not localized to the right ocean basins, and it does not produce the specific pattern of subsurface heat content increase in the Western Pacific that the Tau/Triton array is actually observing. There is no credible peer-reviewed evidence that solar activity is the primary driver of the current forecast, and it is not a data suppression story. The data is public, all of it. The CFSV2 forecast output is available on NOAA's website in real time, updated daily, downloadable by anyone with an internet connection. The NMME ensemble is public. The IRI forecast plumes are public. Argo float data is public. The Tau/Triton mooring array data is public. I am not working from leaked documents or insider sources. Everything described in this video is sitting in publicly accessible databases that anyone can query right now. The reason the multi-basin compound event story is not prominent in mainstream climate coverage is not that someone is suppressing it. It is considerably more mundane than that. The Singh et al. Finding requires synthesizing observations across 3 separate ocean basins, understanding the teleconnection mechanisms between them, and connecting that synthesis to a historical attribution study that most climate journalists have never read. Standard El Niño coverage has a clear narrative structure. The Pacific warms. Here are the regions that get drought. Here are the regions that get flooding. And here is what it means for hurricane season. That story can be told in 400 words. The multi-basin compound event story takes considerably longer. Complexity is not conspiracy. It is just complexity. The absence of mainstream coverage of the Singh et al. Configuration is evidence of a communication gap, not a suppression. And that gap, not any conspiracy, not any manipulation, not any classified weather technology, is the actual problem. Because the configuration that paper describes is assembling in real-time observational data, right now, detectable and nameable and discussable using publicly available information, and the window in which the information is most actionable. The window before the event fully verifies is the window we are currently in. Part 12. If it verifies, suppose the forecast verifies. Suppose the spring predictability barrier recedes over the next 2 months, and the ensemble spread narrows, and the trade winds weaken, and the Kelvin waves complete their eastward transit, and the Niño 3.4 index crosses positive 2.0 degrees Celsius by October and keeps climbing toward positive 2.2 by December. Suppose the Indian Ocean dipole commits to a positive phase In September and October, precisely when the El Niño is approaching its peak. Suppose the North Atlantic remains anomalously warm, as it has been for 2 years, and the atmospheric teleconnections from that warmth compound the circulation anomalies that the Pacific and Indian Ocean forcings are independently driving. Suppose the multi-basin alignment that Singh et al. Are documented in the 1876-78 record assembles itself in the global ocean in the second half of 2026. What does the world look like? The physical impacts would be real, measurable, and significant. Global mean temperature would spike. The 2026 annual mean global temperature would almost certainly set a new record, potentially by a substantial margin, because Super El Niño events add roughly 0.2 to 0.4 degrees Celsius to the global mean temperature in the year of their peak and the year following, on top